Welcome to the podcast. I'm Evan Troxel. I have a bit of housekeeping before I introduce today's episode. The Troxel podcast, I'm now collecting feedback. Whether you have general feedback or episode specific feedback, you can click the link in the show notes or you can head over to trxl.co/feedback. It's my goal to continually progress what I'm doing, and I fully recognize that I'm not the only one with good ideas around here. So if you have something constructive that you think will help, please do so at trxl.co/feedback. And again, that link is in the episode's show notes as well. On another note, it was absolutely amazing to see so many great people from the AEC Tech universe and beyond at this year's Autodesk University. Look for a blog post with selfies with previous guests of the show, including the guest in today's episode. So, in this episode, I welcome Marty Rozmanith, the co-founder and chief technology officer at Skema. Marty is an entrepreneur and building design and construction professional with a 30-plus year career in transforming the building industry. As co-founder and chief technology officer at Skema, Marty leads the team developing the Skema software suite, the world's first BIM knowledge reuse engine. Marty's career is a solid mix of technology startups and global software behemoths that give him a unique perspective on the AEC industry. He spent 5 years in professional practice before specializing in AEC software, and he was recruited out of Autodesk to join the startup company called Charles River Software, which became ultimately Revit Technology Corporation. Marty is best known for his role leading the requirements team for the Revit product. When Autodesk acquired Revit in 2002, Marty spent several more years at Autodesk before going out on his own once again to create companies that address modular and sustainable buildings. And before joining Skema, he spent 10 years at Dassault Systèmes as Global Sales Director and Strategy Director for AEC. His work applying modular approaches and digital twins in AEC has been published in the Wall Street Journal, Forbes magazine, and other professional journals. Marty not only holds a Bachelor of Architectural Engineering from Penn State, he also has an MBA from Boston University. In this episode, Marty takes us on his incredible journey through the world of AEC tech, from self-taught programming skills to pioneering the use of 3D and AutoCAD in the early days, to Revit, then post-Autodesk at Dassault Systèmes, and beyond. Marty shares unexpected twists and turns that shaped his career with the common thread of always trying to better connect design to construction. Listen in as we explore the fascinating path that led Marty to where he is today and what challenges he's got his sights set on solving for our industry with his latest venture, Skema. So, without further ado, I bring you Marty Rozmanith. Marty, welcome to the podcast. Great to have you.
Thanks. Great to be here.
I'm really interested in your backstory. You've been through so much in AEC tech, and I want you to tell that story of kind of where you've been to how you've gotten to where you are. I know that there's some stuff in there that is just it's unexpected, and that to me is going to be kind of an interesting jumping off point for this conversation. So take it over and tell us kind of the path that you've been on over the last, I don't know how many decades. You tell us.
Yeah, about 30 years, a little more than 30 years now, actually. Geez, going all the way back. I mean, I started out in professional practice like a lot of people that went into tech eventually. I went and was doing a lot of work with computers when I was in college. I ended up taking an AutoCAD class back in the very early days in the 80s. And it was a drafting class, and I was kind of not liking the fact that it couldn't do 3D. So I took Lisp and I wrote an entire system so that 2D AutoCAD could do 3D models.
Wow.
Well, when my professors saw that, they were like, "You should just teach the AutoCAD lab." So that's kind of how I got into tech in this world. And but of course, I was just a college student who didn't really know anything about professional practice. And so after I got out of school, I graduated into a recession, which is not uncommon I know so many people who graduated into recessions and had to do creative things. So I ended up moving to California, where I went to work for a very small architecture firm, where I had told them all about, my CAD proficiency, but a lot of what they did was hand drafting. So I got to draft on vellum and, do all those things that old school guys did when you first started out in design. Uh, and then the recession caught up with the West Coast, and I got laid off like 9 months after I moved all the way across the country.
Of
So,
course. Yeah.
so so I ended up deciding that I would try to tap some contacts from Penn State, where I had graduated, and a lot of them were in the Bay Area. So I just started reaching out to people, and I landed a job up in San Francisco, which happened to be a happy accident, since that's where the nucleus of tech was in the late '80s, early '90s, and so I started working for an architecture firm up there, and did work on architecture practice and also in structural engineering. And it got to the point where I had worked for a couple firms. I'd been in professional practice about 5 years. Got to know people in the Bay Area. I ended up being one of the co-chairs of the computer forum for the AIA San Francisco chapter. We would have a graphics exhibit every year. So I think I'm the first person to hold a VR competition back in 1994 at the San
Wow.
Francisco AIA,
Yeah.
which was pretty fun because I remember SOM wheeling in a refrigerator-sized Silicon Graphics Indigo computer
Hmm.
because they had a 3D model of the Dubai airport they were designing at the time, and you could walk around it at like 1 frame per second.
Yeah. Yeah.
So,
Wow.
but it was pretty interesting, just to see where things were headed. Um, and I got to the point where I had to make a decision about whether I was going to commit to tech or to continue being committed to being a designer and designing buildings. And I thought, well, if I commit to tech, I'll probably make a bigger impact than I would,
Hmm.
working on designing buildings. And so I did, and I started my own consulting company, and I actually had a lot of clients in San Francisco. HOK was a client, the Federal Reserve Bank was a client, like a lot of people that needed tech infrastructure for anything to do with facilities, whether it was designing facilities or operating facilities. We ended up doing that. Um, and I got to know from the AIA, I got to know the Autodesk marketing people because they actually sponsored the graphics exhibit, and AutoCAD was one of the prizes that was the grand prize for those
Right.
who won the exhibit. And through that relationship, I actually got recruited into Autodesk with the proviso that I would actually move across the country to New England because that's where the job was located, because they had just bought a company called Softdesk. And I had just gotten done implementing Softdesk at the firm I worked at, which was RMW, which is still around today, kicking hard, 30 something years later. And so Autodesk moved me to New England. And I started working on the first software product I ever did, which was Architectural Desktop, which was an AutoCAD based product. And I actually got to the Revit startup because I was out there marketing Architectural Desktop, which that was the number one product at the time. And I was at all the trade shows. So I think the venture capitalists that were backing Revit got my business card at one of the events, I think it was AEC Systems at the time, and handed it to the founders. And one day I got a call from this guy with this Russian accent who said, "You should come down here and see what we're doing." Uh, so it was all very mysterious, and I drove down to Boston, and
No hesitation.
well, no, well, yeah, it took a few phone calls, go, okay, let me go and see what these guys are up to,
All right.
because they were hinting at what they had, and we were trying to do some things in Architectural Desktop at the time, and so I went down, and these guys kind of took a chance. They knew I worked for Autodesk, and so revealing what they were doing was sort of a risky proposition for them, but they decided to show me anyway, and what I saw was the nucleus of something that was pretty amazing.
Hmm.
It was very, very, very early, right?
Yeah.
So,
Yeah.
um, but based on that, I decided to join that team. And there were only a couple dozen of us at the time, and we were in this building in Framingham that everybody calls the Pink Palace. So if you know Framingham, Mass, you know this building. Which incidentally, for full circle, is now where the work bar space that we actually use for Schema is. So actually, one of our employees still goes to that building that he used to go to when he was at Charles River Software. And so, yeah, so Charles River Software was based in Framingham, and we had Developers with PCs connected with hard cables because Wi-Fi didn't exist yet, writing this piece of software in C++. And eventually, we started going to market, and part of what I did was sign up the first dozen customers.
Okay.
I
Wow.
thought of as pioneers. They were really people that I knew from having been not only a consultant, but also some of the more vocal people from my Autodesk days. So, I wanted to show them what we were working on, and some of them really gravitated towards it. Some of them didn't get it. But those that gravitated towards it formed a nucleus of pretty important friends of the family that helped steer us so that we got the product market fit in a way that actually worked for architects, as opposed to just trying to come up with something you can sell. So we're trying to, we were always focused on what problem is it we're trying to solve. And the problem that we chose to solve was coordinating construction drawings and using a model to do that. And so I was thinking of Revit as this rubberized cardboard building that you build so that it'll do your construction drawings, so you don't have to constantly deal with 300 AutoCAD files, which is what you used to have to do before the Revit days.
Right.
There's a lot of we put a lot of things into it because it was a model-based thing and it's driven by a database. That said, for the time we wrote it, that database is a big fat file that sits in a Microsoft file system, so it's not something that's served in a client server database. And it's obviously an old piece of software at this point, even though it's still kicking hard, producing lots of deliverables for people that they're getting paid on projects with.
Right.
But after so we had a very aggressive marketing VP who was the guy who had to market Lotus Notes against Microsoft. So he was just he knew all the guerrilla tactics, and he pulled them all out of his bag all the time. It was a lot of fun learning guerrilla marketing tactics from this guy because he would pull any punches. And we obviously got, I think we were on the radar for most of the big CAD companies, especially since we would go to all the major trade shows and they would see us. We weren't shy. We spent VC money and got huge booths right next to the big players. And that's how you did it back in those days. Today it's a little bit different, although we are rebooting a few of the Revit playbook steps, like the pioneer customers that form the nucleus of your product feedback. And then eventually what we did at Revit, which we're doing now, is that first dozen or so pioneer users that you have, those firms, they're like magnets that attract the next 10 in their region of the country. So we eventually got to the point where we had 100, 120 firms that were our customer advisory board, and we would go around the country and meet with all those firms on a probably twice a year basis, just to go through roadmap and what we were thinking of doing. And we would basically make them argue with each other over what was more important to them. And that worked actually pretty well because we would hear not just what was important, but people advocating for certain things and other people bouncing ideas off. And, we always said, if you ask 10 architects, you'll get 15 different opinions.
Right.
Because, designers love to consider all sides. And so we got to working for us by just having people debate what are the most important things for Revit to be able to do for the user base out there, and what is the 10% that we shouldn't put in there that's special to somebody's practice. And they'll do that by doing something in the family editor or some script eventually that they'll write. And we're doing some of that with Skema now. But after Autodesk acquired the company, I spent 3 years there. I wrote some things which I thought would be useful for Autodesk to implement. A lot of that stuff never got implemented. Partly because I was more of a product guy. I wasn't really a business and sales guy. So after I left Autodesk 3 years after the acquisition, I went and got an MBA because I knew at some point in the future, if I ever did this again, I would have to argue with those business and sales guys about, not just what's a good idea, but what actually makes sense for the business.
Yeah, just speak their language, right?
Yeah. So I went immediately thereafter and got an MBA and started working on my own startup companies. The first ones being all about the building industry, but not about design intent, more about means and methods. So there was one that was manufacturing CNC steel frames off Revit models to try and accelerate the precision and delivery, specifically in multifamily housing. There was another one that we did that was after Katrina hit. Very fast assembly housing for the Gulf Coast that was made out. It looked like a low country Mississippi cottage, but it was made out of lightweight precast concrete. And we physically tested it to 160-mile-an-hour winds. So there's a prototype still sitting there somewhere in Pascagoula, Mississippi, actually. And it's been hit by like 25 hurricanes, and it still looks like
at this point.
Amazing. It's the actual most amazing building I've probably ever put out, but not many people know about it. And a lot of startups like that. Some of them worked, some of them didn't work. Not all of them were in AC. I did a couple SaaS products that were just general consumer SaaS products in web publishing and some other stuff, where I got to learn about running a company, making payroll, general marketing and sales, that sort of stuff. And then finally got to the point where I just decided I want to go back into AC, partly because I knew that Revit would need several years just to kind of get on its feet. And then I just took a look around the industry and thought, okay, where could I make impact now that several years have passed? And so I started looking at the various players, and I thought actually Dassault Systems had some pretty good technology that they had developed. Obviously, the big product everybody knows there is CATIA, and the other one's SolidWorks. So those are all modeling products, but they actually have quite a large tech stack that's used in aerospace and automotive industries. And given the fact that I had been in some manufacturing startups, I thought, all right, well, if I have to figure out, how to apply some technology and some work practices from manufacturing to construction, Dassault Systems is probably a pretty good place to do it. So I went and spent 10 years at Dassault Systems, kind of advocating DFMA and productizing and industrializing construction to make it more efficient. And that whole thing about trying to connect design to construction is something I've been doing ever since I was in college. I wrote my thesis paper at Penn State back in '89 on a system to connect design and construction. I came across it in my basement the other day.
Wow, that's cool.
And so there are some of my colleagues who refer to this as a disease. Like, we've just been at this for so many decades, we can't leave it alone now. And that's kind of how I am about it.
Wow. There's so much there. I kind of want to go back to the beginning for a moment, because you wrote your own 3D modeling Lisp routines for AutoCAD. Where did that come from? Like, what? Because they don't teach C++ or Lisp in architecture school, right? And so obviously you're self-starting. And so I'm just wondering, like, why did you decide to do that in the very beginning, and how did you decide?
Yeah.
How did you accomplish that?
So I wasn't in an architecture program. I was in an architectural engineering program at Penn State. And so you're pretty technical when you're in that program. But the, computers in that program, these are, this is 80s. So I think ETABS existed. So you used it for structural simulation, but there wasn't really, other than general drafting software that people use for mechanical CAD, there wasn't anything specifically dedicated to AEC at the time. And so I was actually trying to rationalize a project that was a multifamily residential project that somebody I knew was working on, and it was all to do with roof slopes and stuff. And so I just said, how can I make this do it? I wrote my first computer program in middle school. I wrote a game for the Apple IIe, which was a Moonlander game. Most of the game was in BASIC, but in order on a machine of that era to get the graphics to be fast enough, you had to write them in assembler, which is basically raw machine code. So, in middle school, I learned how to write assembler code. Wow. And so I wrote this game, and eventually, in sort of computer circles, I got you would pass things around on floppy disk, and I got this floppy disk because I had this Moonlander game on. I'm like, I wrote this game.
That's awesome.
So I had written programs ever since I was in middle school, and so I just, it was mainly self-taught, just learning how to do programming.
Was that out of books? Was that out of magazines? Because I remember
it was out of mostly books and trial and error.
Yeah.
I wrote those programs on an Apple IIe. The school that I was at had Apple IIes. I eventually got like an Atari 400 that I wrote basic programs on at home because it was a little bit better than having a game console. So somehow I talked my parents into it.
Nice.
Um, but I just had a general awareness of what it takes to write something like that and the structure of it. And I realized that this Lisp language was something that you could extend functionality with in AutoCAD, so that I just did it. Um, I don't know, I just didn't think too hard about it. I just started working on it and
That's
figured out how to structure it, and it worked. Probably nobody else would ever be able to figure out how to use it, but I
right.
got it to work, so it was okay.
Well, and back in those days, AutoCAD was running on DOS, right? And
Yes.
just to kind of reiterate the things that you're saying, the first thing that my first computer was also an Apple IIe, and I would
Mhm.
program things in BASIC. And you're much more of the engineer side of architecture, and I'm much more of the designer side of architecture, because
Mhm.
going through that process, my first personal computer was a Commodore 64 that I bought at Toys R Us of all places, right? And I wrote, like you, a game, but I copied it out of a magazine. And that's what we had to
Mhm.
do back then, right? I had to read the text in the magazine and then, or a book, and try to write that same code, and then go back and find
Mhm.
where I made a mistake to
Right.
fix it. And I realized right then that I was not going to do that anymore. Like that,
Yeah.
because even then on the Commodore, it was like, how do I can save this to a floppy, but at some point, like that program was just lost, right? It was just
Yeah.
gone. And for you to stick with it and then to take it to those other levels, I think it just shows how, like, we're coming at this problem of
Right.
architecture and AEC from different places. But I find it so fascinating that so much of the innovation that we see today is based off somebody scratching their own itch, and the intrinsic
Right.
motivation of people to teach themselves a thing to do to make something happen. And that just set the whole trajectory for your entire career. It's just kind of incredible to look back at it and think about it that way.
Yeah, it's pretty cool. It was, it's also just being given the opportunity to do some practical applications so that you have some confidence. Like, my mother at the time was a dentist, and she had this crazy thing where she had these file drawers full of like index cards where her staff had to figure out, all right, months from now, we have to send this person a reminder to come in and get their teeth cleaned, right?
Yeah.
And I'm like, that's such an easy problem to solve for a computer. You don't need
Mm.
an army of people sorting through index cards every week trying to figure out who the hell they should mail things to.
Mm-hmm.
So I actually took the Atari 400 and I wrote her a database program that would manage the entire like process of essentially scheduling people 6 months out to do this, and then basically printing all the labels that they could just use to stick on a postcard to send it to the person. And so, when you get the opportunity to do some practical application of just some strange, weird skill that you have as a computer nerd,
Mm-hmm.
and you actually see that all of a sudden, like these 10 people actually made their job easier.
Yeah.
It's very encouraging. That said, I didn't really know what I was going to do when I went to college. I thought I might do computer science, and I really only applied to Penn State and the University of Texas at Austin.
Mm.
And UT lost my application. I was like, well, they don't have a good database if they lost my application.
You
So
disqualified them.
yeah, so
They,
they disqualified themselves, and then Penn State accepted. I was like, all right, well, this is an easy decision. I'll just go
how
there.
funny.
But like I had to figure out a way to get on the main campus, and so I actually applied as a ceramic science and engineering major, and eventually switched into architectural engineering.
Mm.
But sometimes things happen for a reason, and you just end up where you're supposed to be, and that's kind of how it worked out.
Yeah, super interesting. What you talked about, that the 10 people who found value in the thing that you did, and
Mhm.
that still drives people today in AEC who are writing Grasshopper scripts, right, for their own
Yeah,
studio, or
exactly.
and it's Dynamo and Grasshopper, and the visual coding, no code kind of tools that people now have access to, very different obviously than what we had growing up from a programming standpoint, but that
Yep.
people still enjoy doing, experiencing that exact
Exactly. Yeah.
scenario. And that's still what drives a lot of innovation in AEC. It's actually pretty incredible that that thread is still alive very well.
Yeah. And so I kind of stopped directly writing code myself because I realized, having done it a few times, that there were people way better than me at writing that
Mm,
code. And once things got complex enough to be C and C++, I was like, I'm not the best guy to write that code, because that's like you have to gone to school for that and know that sort of stuff and heavier
and be
math
in it
before
every
you can
single
learn.
day, right? Like you just
And
have to
I learned some
do
pretty
it.
heavy math being a structural engineer, but
Mm,
the computer science guys have a whole different sort of field of math that they have to learn in order to do some of the stuff that they do, and that was just not where I was schooled. So when I got back into technology as a consultant, and then eventually back into software, it was more defining the product requirements because I knew how a software engineer thought, and I knew how a design professional thought, and so my real skill was being able to translate one set of vocabulary to the other set of vocabulary, so that the software engineer would understand the problem they were trying to solve and be able to talk to the designer and understand, this is what I really needed to do. There are people who tell you what they want, but your job is to figure out what it is they actually need.
hmm.
Because, what was
Yep.
it? Henry Ford said, if I asked people what they wanted, they would have said a faster
Yeah.
horse, right?
Yeah.
So the art of it is understanding how to take the input and then morph it into determining what the actual underlying needs and root causes of that request are, so that you can then turn that into something.
I'm interested in the Charles River early Revit days just from the standpoint of like what were you inspired by? Because I know there was a few other or maybe just a couple others BIM tools at that point, but was it really, I mean, did you have the foresight to kind of understand what the potential of what you were doing was and were there other examples or were you really just solving the customer's problems, trying to pull that out of them to define what the things were that they actually needed to practice efficiently?
I thought what we did at Architectural Desktop was quite a significant development in software, because
Mm,
we got away from lines, arcs, and circles, and we had objects that were actually representing real world things as far as wall to window.
yeah,
The
I
thing about
remember
that
that.
piece of software, that it was pretty limited by the infrastructure of AutoCAD that it was built on. So
Mm,
the software R&D team did as great of a job as it could by building this entire infrastructure called Object ARX, that would enable these things to work, but it was, purely speaking, kind of clunky. And the workflow of AutoCAD, where you had to basically do one floor at a time in files that, there was an entire XREF structure around that,
hmm.
meant that you had to do a lot of pre-planning before you ever did any design work.
Yep.
Um, and so one of the things I recognized when I saw Revit was that entire presupposition of having to do things one floor at a time and having an XREF structure and all those things that were sort of the computer-esque side of using an AutoCAD-based solutions didn't exist in Revit, because it was just a clean page rewrite of a building modeler. And in fact, the branding of Revit was not BIM. BIM was something Autodesk invented as a marketing concept, but the
Mm,
branding of Revit was the world's first parametric building modeler. And what
mm,
parametric meant was something up for debate. Parametric, in our view, was the change engine that allowed it to coordinate construction drawings, whereas most people now think of parametric in terms of shape generation, like Grasshopper or Dynamo or things like that. But they're both valid definitions of parametric. But
yep.
the Revit parametric engine has more to do around coordinating sheets than it does geometry. And of course, after I left, I think the people who became product managers, who were all very interested in shape generation, put those sorts of things in there because the market wanted it.
Mm,
So now Revit does both. It does shape generation and the coordination of sheets. But in the early days, the first part was that you could design a building and you didn't have to pre-plan how you were going to organize the data just to make the computer serve your purpose.
hmm.
That was the first thing I saw. The second thing, which was my real big concern, because I was working at that point for the number one product, being pretty well paid and having, I don't know, 50,000 users, was how is this small team, um, who obviously have some bright people, not just going to get crushed by a behemoth like Autodesk. And it was the CEO that they had just hired said to me, Big companies are just structurally incapable of doing certain things, right? Just basically we're going to outrun them because we can just develop faster,
Mm-hmm.
which is exactly basically what happened. It
Mm-hmm.
was that you didn't have to support the legacy infrastructure of a solution that was driving whatever, $1 billion of revenue, $500 million of revenue. And so you could just move a lot faster because you didn't have any of those considerations to deal with. And so I just learned a lot about startup companies from the original Revit founding team. It was a fantastic team, not
I
just
bet.
the R&D team that wrote the code, but the client support team and the marketing team and the sales team and the executive leadership team. It was just an entirely fantastic team on all sides. It was a
And
great
what
place to learn about it.
and what year was that? I mean, what this is like pre-Revit
Yeah, I,
1.0,
I
I
joined in
assume?
the summer of 1999,
Okay.
and
Wow.
I was employee 26, and I think Dave Lamont was employee number 25, who was the CEO. So, and the two founders, Leonid and Irwin, they had started the year before with a space above a pizza shop. So I wasn't in the space above the pizza shop. I didn't quite even know where that was, but we were in the Pink Palace in Framingham, and then we soon moved to Waltham after that because we started hiring people really fast. Because once the customers started showing up, then you have to respond.
You got to
So
deliver.
yeah,
It just to put this in context from my point of view, I graduated college in 97,
mm,
and so I had used AutoCAD release 12 or 14 maybe, and
yeah,
3D face commands to learn 3D modeling, and we actually had a Form Z lab. So that was where I
yeah,
was. I wasn't in the building information modeling database world at all. It was still
yep,
very much file based. And this whole XREF thing that you're talking about, like the whole point of that is so that multiple people can work on a project at the same time, right?
right,
Because of
yep,
course you could CAD the whole thing in one file if you wanted to lose it all at once, I guess. But
yeah,
the whole point of that was so that you could have the elevations over here and the plans over here and the sections over here, and people in the office could be working on those, and I guess assembling the sheets
yeah,
happened via this really cool dynamic system of XREFs. And so there was like that AutoCAD world, and then to me it was very separate working in
yeah. The
3D.
two were very separate. You had designers who worked in 3D modeling ish
Right,
stuff like
right,
Form Z, and then you had production people
right,
who made the drawings that they got paid for, and that took a lot of planning. You had a CAD manager, right, who
right,
figured out how the whole thing had to hang together.
right.
And every job had a job captain who just figured out what is the sheet set and what do we have to do from a file standpoint to make that sheet set plot at the end of the day on a plotter, right?
Which, wait, and this is still happening in Revit. Like there's still
Yeah,
this huge discussion at the beginning of every project of how are we going to
right.
assemble this? Is it going to be every building's in a separate file? Are we going to have, like what? There's still a lot of time spent trying to figure
Yes,
that
there
out.
is.
And I know this is something that you guys are going to be solving as well, because this has the thinking has shifted, in that like this isn't the kind of thing we should be spending a ton of time on every single project, still
Right.
hours and hours, and then switching it sometimes midstream because something changes on the project, and it is still quite a bear to deal with, I think.
Yeah, one of the things that I did early in my career in San Francisco was the architecture firm I was working for had um, United Airlines as a client, and when the international terminal at SFO kicked off, United called us and said, "We know we have a lot of space at San Francisco Airport. We have
Mm.
no idea how much it is or where it is." So I got this field survey. I got the
Wow.
field survey, San Francisco Airport. And, that takes a long time. Um, and put it all into AutoCAD just to be able to show them where all the space they had was. Which was, it was, in the days before they were highly security conscious. I still had the palm scanner in order to be able to walk out on the tarmac and,
Mm.
measure the outside of the airport. But I eventually put together a set of AutoCAD files that showed that they had 2 million square feet.
Wow.
And so then there was this plan of, with the international terminal coming online, how they were going to take all of those people and move a bunch of them over there, and then what space they were going to keep, what space they're going to get rid of. It was massive, like move, add, changes problem. And there was nobody who had the appetite for trying to figure out how to do this with hand drawings. They were like, How are you going to do this using AutoCAD? And so what I ended up doing was I ended up taking an Access database and kind of a rough facility management system, connecting it to AutoCAD. And I would literally print a color book like that thick every week with just everything they had decided to do with the space. And so it was like it was a massive publishing job every week just to put out 2 million square feet of SFO space for United Airlines. And so that really got me to the understanding of what it's like for a database to drive a drawing production system. And the
Interesting.
reason that I wanted to go work for Autodesk when they made me the job offer was that up until that point, production of drawings and design were very separate things. And I saw Architectural Desktop as really the first place where you might be able to do design and production in the same system. And then I ran into a lot of that, the presuppositions of AutoCAD, which designers didn't want to have to deal with. So then when I saw Revit, I said, oh, well, this is even more in the direction of some place where we might be able to do design and production in one system. And I think it's just been constantly trying to get to that point where, because what I would like to be able to do is design, production, and then construction all in one system. That's where the thesis I wrote back in '89 was around connecting design to construction so that all of that data can inform the means and methods, not knowing anything about the fact that an architect is a special kind of lawyer and that you don't have insurance that covers anything after the deliverables, and you can't inform means and methods. Otherwise, you're open to get lawsuits. And so there's been very interesting business, having the part of the good of having the MBA is now I understand all of the things that prevented this from happening weren't actually technical things at all. They were all legal things, right? Mostly legal and insurance constraints that caused that from happening. And spending 10 years at Dassault Systems looking at how OEMs do cars or airplanes or elevators or industrial equipment like Caterpillar, you see that it's just a totally different organization because manufacturing is only about 100 years old. The law predates manufacturing. Well, like construction's like thousands of years old. It predates the law. And so the law in some ways was developed based on construction practices. And what you find is actually that construction practices are the same wherever you have English common law countries. And then in other places like France or other places where they have different laws, you actually have different construction practices because the two are sort of inextricable from one another. And so we actually have interesting things that go on in countries that are not based on English common law, because now technology is not the constraint. And if law and insurance is, in those places, they're different law and insurance. And so you can actually learn from those places. So it's been a fascinating, one of the things Dassault Systems did for me was it gave me a platform to see these differences worldwide that you wouldn't really be able to easily see if you were working for a smaller company.
Yeah.
And that's been great for informing what's going on now with what we're doing with Skema.
A friend of mine, friend of the show, Clifton Harness from TestFit, he said, if you want to be innovative in architecture or in technology, he said, you start with the OAC contract, right? Start with the owner architect agreement because so much of what we do is based on that. And there's only so much we can do because of that, right? I think that what you're saying is right in line with that. And it's incredible. Insurance, law, contracts, like all of these things, permitting agencies, it's still based on printing. It's still based on that PDF.
Right. It's based on the artifact. Yep. And this is one of the things I learned from having tried these manufacturing companies and seeing how the OEMs do it from my time at Dassault is that in every other industry other than construction, there are process engineers who have process diagrams of the way things happen at an automotive manufacturer or at an aircraft manufacturer.
Sure.
And in fact, those process engineers have conventions just like other professionals, and they compare their process diagrams to other people's process diagrams. And eventually, after 20 years, the industry comes up with a best practices process diagram for standard operating procedure for an automotive plant or an aircraft plant or whatever. So you can literally go to a consultant and say, what is the best practice process for an aircraft? And they can tell you.
Yeah.
And nobody in AEC can.
Nope.
I'm probably one of the only people who's ever tried to diagram using BPMN5 the design and construction process, and it's
Right.
an impossible problem because what happens is,
Every project's different.
depending if you're doing a hospital, you've got medical gas consultants, and you've got a whole bunch of piping that doesn't exist in any other building, and so the scope is totally different. If I'm doing an airport, I've got a baggage handling consultant
Right.
who knows all about conveying systems, and those are all completely different, and so the scope, the contract, and the team changes depending on
Every
the
time.
type of project, and the
Yep.
process changes with the team.
Right.
And so it's very, very difficult to use any process-based system like PLM in manufacturing to try and manage
Mm,
the construction process because that's just not how it's organized. And part of what I learned from comparing the two is that really what AEC is organized around is artifacts. Architects will make an artifact and then they'll go back and say what worked, what didn't work. Okay, on the next one, let's not do this. Let's do this instead. And then they learn. They learn from artifact to artifact, which is we're literally directly implementing that into Schema, where you take this old Revit stuff that just been sitting there doing nothing, and we learn
yeah.
from that and put it into the new project, so it's just a lot easier to use. And anybody who comes from manufacturing will always think of, okay, how do I? They always start with process first and try and impose process, and
Hmm.
realize after a while that's not how it works here.
I've had
It
that
works with
exact same
contracts and
experience.
transactions. It's just fundamentally different.
Yeah, a guy that I worked with on a project out of San Francisco at Project Frog, we were doing some prefabricated school stuff. And this guy, Ash, he had come from automotive, and it was like
Yeah,
3 years into Project Frog, and he was still like, I cannot believe how hard this is. He thought it would just directly apply. He thought
yeah.
they were just gonna figure it out. And to your point, it was just like impossible to figure out because every project is a different set of rules, constraints, team members, inputs, outputs. It's all different all the time.
And so there is a way to learn from manufacturing, but it's not by the by replicating the process they use to make things. It's rather you can productize pieces of construction and then use that to make overall construction more efficient. Like a great example is an elevator, right? An elevator is a manufactured product, yet it's
Hmm.
different for every building because every
Hmm.
building is a different number of floors, a different floor to floor height, a different structural system. And yet somehow they manage to manufacture an elevator on schedule and install it and maintain it.
Right.
And there are
But they are,
certain
always broken, Marty. I'll just say that.
well, it's yeah, yeah. There are certain companies trying to apply that, specified and delivered by owner principle to
Hmm.
certain very time sensitive buildings like data centers. Like just don't bother the contractor with assembling the guts of a data center. We'll do it ourselves, kind of thing.
Hmm. Hmm.
Um, but McKinsey, and so especially the systems, they took notice of this. McKinsey wrote a report on construction heading towards modular, and they said 25% of the value chain of construction is going to move towards modular, which is in many hundreds of billions of dollars of work in place. And I think finance people saw that and said, "Oh, construction's turning modular. There's a huge disruptive opportunity. Let's get in the game." And that's when you saw all of these like AI-driven configurators doing massing based on developer performance pop up, right? And all of a sudden, they were just going to come up with a feasibility study, and we apply some modules, and boom, we have an end-to-end solution. And I see that, and I say to myself, McKinsey might be right, but that doesn't mean construction projects are going to be 100% modular anytime soon. Like you can look at a hotel, like what Marriott's doing with bathroom pods, right? And
Hmm.
the hotel is still engineered to order, but now all the bathroom pods are modulars that they're shipping as units, right? Or unitized facade, or even kitchen pods, or things like that. I see that as modular penetrates the construction value chain, projects are going to go from 0% modular to 20% modular to 30% modular to maybe
Right.
40% modular. But the most advanced work I've seen in modular in construction, other than very simple buildings, is like 70% modular. Because every time you got to interface with the ground, it's not going to be modular anyway. So,
Hmm.
so I see this, and part of the reason that I decided to make Schema in the first, leave my fairly comfortable job at Dassault Systems and go ride the wild bucking bronco of a startup again,
Uh-huh.
was the fact that I didn't want to see a world where the engineer to order stuff was done in Revit, and then there was this other system that dealt with the 30% modular stuff. I was like, designers will lose their minds if they have to design half the building here and then half the building here, and then try and figure out how it all fits together somehow. And so that's part of the motivation for taking this on at this point, which is I see what's coming from a execution standpoint, and designers can't directly get ahead of means and methods, but the systems can evolve so that they don't have to.
Hmm. The perfect segue. It's time to stop burying the lead and talk about Schema here. So by the time this episode comes out, it will have been November 1st. It'll be past your release date. So give us an idea of what Schema is. So like just let's start on the outside and work our way in.
Yep.
Tell us what Schema is. You mentioned that you've moved from Dassault into Schema. And you didn't think that you would get back on the wild bucking bronco. So tell us kind of what was the spark there, and what is so exciting about the work that you're doing now? What's the potential here?
Yeah, so I guess I'll tell you how I became aware of the technology team. So these guys in Eastern Europe had written this really bunch of prototype code libraries for doing modular residential production. And so they had written configurators, different types of configurators. They had written some for apartment buildings, some of them for mass timber office buildings, some of them for parking garages. They had they just had this competency in writing configurators that dealt with manufactured systems. And so they were trying to figure out a way to bring some of this technology to market, but they didn't, they had good technology. And the most amazing thing about this technical team was that they didn't write this on somebody else's tech stack like Forge or something else. They wrote all of their own math, just like the original Revit team did. The original Revit team had to write its own 3D engine, its own constraint solvers, its own all of this stuff, right? Mm-hmm. So the entire tech stack was written by that original Revit team, which is why in some cases Revit was so weird about what kind of surfaces it could do, because they wrote their own surfacing engine. And so this team wrote all of its own tech stack, and they decided that the ultimate manifestation of the tech stack was these configurators. Well, one of the things I decided to do before leaving Dassault Systems was that I was going to see if I could pioneer a way of showing this change in construction that was coming towards modular, and ended up going in with a friend of mine who was also a licensed architect and done some commercial property development on a multifamily commercial apartment project in Massachusetts. And we had talked about, doing things that most owners wouldn't be willing to do, and doing this for affordable housing, not by making them cheap, but by using modular delivery to drive down the delivery cost of the facility so that we could produce housing. It wasn't affordable housing. It was just housing that was affordable, which in Massachusetts is almost impossible.
Okay.
Right. Because our rent structure is the same as San Francisco or all the other big tech places. And so we said, all right, we'll do this as a project because we understand design and construction, and this is just a good thing to do to show this as a project. But we also want to use it as a test bed for software. And so after I left, these various configurators that came out, all the ones that were done by private equities since about 2017, the Archistars of the world, the Delves, the Spacemaker, which was bought by Autodesk, all these configurators that come up with a project feasibility analysis. I wanted to say, as someone who's designing a project on a real world site that has slope differences and has, a podium that has mixed uses like parking and commercial and then residence above, could I actually use one of these things to do a real project? And we applied a bunch of them, and none of them worked. And so we actually we hired an architect out of Boston. And after we went through these experiments, he ended up doing it in Rhino. So we reached out to some of these tech companies, and we were like, look, we tried to use your system on this actual project, and here's why it didn't work. But we, basically recorded the charrette we did in Zoom, and we'll send you a copy of it so you can see how we actually did it.
Mm-hmm.
And these guys that had developed what is now Schema got back to me and said, okay, let us work on it. And so, I don't know, several weeks later, they were like, hey, can we have a Zoom meeting? So I had a Zoom meeting. They're like, we did it. We wrote what you wanted. It's like, what are you talking about? So they showed me this thing, which was called Schema, which was basically some implementation of the ideas of, solving this multifamily project in Massachusetts using their residential configurator, but now with this easier to use front end on the front of it. But all the back end hard math was all the stuff that they had written in the past.
Right.
And I had actually put this company on the Dassault mergers and acquisitions team roadmap, but a couple years passed and so decided not to do anything. And so I thought to myself, well, if these guys actually have a way of solving this problem, that might make a good piece of software.
Mhm.
And so probably half a year after I left Dassault Systems, I started talking to these guys about doing a deal where I set up a company to acquire the technology because we know we have an idea of how to take this to market, and let's do that. And so that's what we did. And we signed an agreement with them at the end of last year and started working on adjusting the roadmap in the spring, and essentially launched it at the AIA show in June, where people got to get their hands on it. But at that time, it was still very modular. So it was very much a modular configurator for apartment buildings. And that's what it could do, because that's
Mhm.
basically what the original prototype code they had written was. And what we're coming out with by the time this airs is all the work that we've done with architects over the last 6 months to take that idea of a modular configurator that can make apartment buildings and turn it into something that is far more general that can apply to all buildings. And so, in short, what Schema is a conceptual design system that can learn from your previous Revit projects using the layouts for things like, let's say you're doing a healthcare facility and you have exam suites and labs and surgery suites in previous Revit projects. It can farm those things out of the Revit projects and put them into a concept catalog. So then when you're trying to resolve the partie of that healthcare facility, you can much more easily at a sort of Jello cube moving things around level, solve the partie. And then because we know what Revit data it came from, we can generate the Revit model out of it without you having to take the 2 intervening months to manually model wall or window to represent what those Jello cubes are in Revit. And so the idea there is that from a metaphor standpoint, you're bumping up one level from walls, doors, windows to working with whole chunks of buildings as the way an architect would think about the program. So I almost call it meta BIM, in that I'm not doing BIM at the object level. I'm not doing it at the whole chunks of building level. But the chunks are things that you've done previously that we're reusing in a systematic way. And so what's interesting about this is that we give you a conceptual design environment where you create a mass and then you start applying these catalogs to do the block and stack. But even if we had an architect that started out on the same site with the same mass, their catalogs look totally different because the data in the Revit projects is different. So once they generate the Revit models, architect one is going to have their wall styles and their doors and their windows and their furnitures, fixtures, equipment, lighting, all of that stuff that comes from their catalog of work is what appears in their Revit model for that project versus the architect two, their catalog of stuff is completely different. So what's interesting about this process and this systemization of the design process is that you don't lose the individuality of the architects. The buildings that result look like what that architect made, because it came from their ingredients. And now that some of the architects that we've been doing charrettes with and have been putting this on project realize, they can basically resolve a whole bunch of the building, and then they can start having design exercises separately on facade and how they want the building to look. And, so they can resolve form, they can resolve function, and then they can get into variations of that to serve how they want the building to feel from the outside and the inside experientially. And part of what we're trying to do is, our goal is never to make 100% complete building. We describe ourselves as a fast forward button, with the idea that we're the fastest way to get to 60% complete. So that would take you 2 months. We can do it in 2 minutes. And then you just take the result of that and do what you normally would as an architect in Revit. It's just, we take a lot of the boring stuff that you have to manually do out of it, so that if you have all of the things that are experiential about the building, the entry, in some cases in a healthcare facility, the signature waiting area that's multi-height and, got all sorts of interesting things going on. That's where you spend your time as an architect, not on laying out patient rooms and labs.
Starting over yeah. So my marketing brain is going, and so Mark, what is your 0 to 60 time?
0 to 60?
0 to 60%. Like that's your goal, right?
Oh, yeah.
The fast forward button. So what
Right.
is your 0 to 60 time? What does that actually look like for somebody who's using a tool like Skema or using Skema?
So we typically, we have a very risky marketing and sales approach in that I've worked for many, many large software companies that will do death by PowerPoint. We typically will do one of those just to get people to understand what we're talking about on Zoom. But our typical approach is we sign an NDA because we're going to have the architects send us their Revit models. For anything that we're going to use in a charrette with them, they have to send us 2 or 3 Revit models of that project type. So it's not like we're getting a big data lake with thousands of Revit models and training it on something. We need 2 or 3 Revit models. And then from that, we will go into their office. They will invite people who've never seen Skema.
Mm-hmm.
We'll make the accounts the first half hour of the meeting after they introduce themselves. We'll teach them how to use it in an hour. 2 hours later, they will have a building in Revit, which they didn't think was possible before they walked in the room that day. And so that's generally, that's our biggest hurdle is convincing people that what we're talking about is not magic science fiction in the future, that it's actually here and that you can actually use it right now if you want to. So our 0 to 60 time is about 3 hours.
Wow. It's got to be really satisfying to you to watch those people's aha moment, right?
Yeah.
What is that like as this goes back to your early days when you wrote the thing for your mom, right? And it was like when you saw 10 people using this tool that you had made, and in this case, again, like achieving what seems to be impossible for most people to comprehend, like what's that like for you?
It's interesting, and there's a lot of different flavors of those aha moments.
Storming out of the room, people just pissed off.
Some people are like, "Holy crap, AI's coming!" But other people, and when we hold one of these charrettes, we like to mix senior people and junior people. We've had people who are senior because a lot of the people, we have a conceptual design environment that does options, right? So it's made to do presentations to win work. And a lot of your senior people are the ones going after those projects, and they're losing 2 out of 3 projects because that's the win ratio, right? And so they're spending a lot of their time at risk. So we've had senior people like that come in. They certainly don't use Revit, but some of them don't even use SketchUp, and they've used this thing, and in 2 hours later they got a building. That quickness of win gives them confidence that this is not for other people. I can actually do it. So that aha moment is different because that can sometimes be a little scary for them because they've always done everything on trace, right? So that's one level of aha moment. The other one is the junior people in the room, right? So senior and junior people in this type of charrette. When we first came out with Revit, it was interesting that a lot of people, at the beginning of this call, we talked about, the people doing production with XREFs and AutoCAD. And at that time, in the 99, 2000, you show somebody Revit, they're pigeonholed doing production in AutoCAD 10 hours a day. And they see this Revit thing and go, this is my way out of being pigeonholed in AutoCAD. And what's interesting about the aha moment for these junior staff in these firms is they see this and they go, wait, this can do my Revit production work. This is a way for me to get out of being pigeonholed in Revit doing production work. And now I can do more interesting things. So it's just the parallelism between those two that's one of the biggest surprises, actually. I had not anticipated that. That's just come out of seeing the reactions of people and using it on projects.
Let's talk about what it's like to actually work in Skema. What you showed me was, I loved it because we've built scripts that have done this, and it was arduous process. So what you're doing makes everything that I've done in the past seem completely obsolete. But the idea of just drawing a line of circulation, and you pick a site, it's got a slope to it, it's got contextual buildings, so you've got kind of an environmental aspect to this thing. Obviously, a building site is not in a vacuum. You need context, but you started off with this very simple concept of circulation and the kind of the double loaded corridor condition.
Yep.
And then based on the architect's kind of library catalog of spaces that you mentioned earlier, you then kind of built the blocking and stacking based on a very simple version of those, and it automatically kind of populates, and then you start to move things around. This was a very dumb version of what you explained. I'm sure you can explain it much better. So talk about what it's actually like to use the tool.
Yeah, it's interesting because Architectural Desktop had a massing tool and a spaces tool, and Revit has a massing tool. So this is, we had one called Building Space Planning at Dassault Systèmes. So this is like my fourth time around on massing and space layout tools. The thing about Schema is that it's extremely fast and flexible, kind of like SketchUp, but it's not just about making faces and shapes. So the idea is you start with a site context, right, with the surrounding buildings and all of the things that you have to consider. And you basically start out by blocking mass. And you don't know whether the mass you have is big enough or not. You just got some rules of thumb based on whatever brief you have about where the building should be on the site, based on sight lines, sun, views, noise, whatever your criterion is. But once you get to, you might do 3 or 4 different massing options just to try different things. Within each of those massing options, you're going to assign space usage so that you can, from an analytics standpoint, see how much of each use do I have? Do I have enough of each use based on the briefs that I got? How can I solve the brief creatively on this site several different ways? And once you get to that point where you have things roughly sized, both from a mass and space use standpoint, you can get into simulation. So you can look at sun, you can look at daylight, you can look at those factors to say, oh, this mass doesn't work because I'm blocking all of the sun access to this adjacent property. Daylighting's bad in this condition because of whatever other feature I have in my context. So you can rule out some of your massing options based on just some simulation. And we expect that to just get more robust as time goes on, because simulation is just one of these things in conceptual design being plugged in. I mean, if you look at Forma has a dozen different simulation engines for everything from wind to noise to whatever you want. And then once you get down to a couple different options, that's when you've got to see if it's feasible. And that's when you really try and fit the pro forma in by doing the blocking and stacking and figuring out the partie for the building. That's where we really shine, because that's when we can actually help, just starting with circulation and exiting, then fitting in the parts of the program that you need to fit into that mass. And you don't have to do it in that order. You can go to the block and stack and realize, oh, I actually need to change the mass, and then just turn that off, change the mass around, and then reapply block and stack. So it's iterative in that way, and that it's not sequential. You can go in whatever order is useful to you. But eventually what you end up with is a site context that has some mass that you've worked out because you've simulated it and it's working from all of those simulations, and you've resolved the brief as far as the partie and the block stack in that mass. And then once you're at that condition, that's when you can just instantly go to high LOD Revit data, because everything that you've got there represents a placeholder for chunks of buildings that we have in that catalog library that can then reconstitute the building from that higher level meta BIM type of arrangement that you've developed. So you don't have to think about the BIM. It ends up being a byproduct of that conceptual design process that you've done in Schema. And in fact, for us, the two things are different systems. Schema AI is the conceptual piece that you actually do all the conceptual work in. And then once you have that resolved block and stack, that's what we use in a backend system called Schema BIM that actually generates the BIM data. And what we do is we take that and preview it in Schema so you can see what it looks like. So you could say, oh, that's not what I was expecting. And then you can turn that off, change the block and stack, or get rid of the block and stack, change the Mac, reblock it. So again, like the whole point of generating the BIM is so you have a touch point of, did this work the way I was expecting, or did some weird thing happen when I actually turned it back into a building? But what's nice about that is in the current process, you would only find that out after a couple months of painstaking work. Like you would get to the point and you'd be like, oh, I didn't like, that's not what we should have done. Here, you just get that answer in like a minute and a half. And if you don't like it, you just go back and try something else.
Yeah, I was going to bring that up because how much time do we waste as an industry in that feedback loop right there, right?
Right.
Because it does take time to figure all of that out to only find out that, oh, that didn't actually work. And so then you either have to decide to spend the time and do it again, or you have to just say, uh, we're going to try to figure that out later, right? Or as we
Right.
go, right?
Yeah.
And that's both of those are painful decisions to have to make if you didn't do it right the first time.
Yeah, and I mean, design is an iterative process, so you're going to go through that. It's just what is the easiest way to get to the best answer, you know?
Yeah.
So that's what we're trying to deliver in this. And I honestly believe in two things with software, and that this is always applied for any software I've ever done. The first is you have to meet the mere mortals test. So there's software that works, but normal humans can't use it.
Right.
And this is part of the problem with some of these things like Grasshopper is like that principal that doesn't use SketchUp, she's not using Dynamo, right? So part of this is the mere mortals test. So a lot of what we do, we prototype in things like Grasshopper, but eventually we want to take the 80 to 90% that really shouldn't is the common thing that everybody needs to use across the board. And that goes into Schema, which is a web app where you don't have to install anything and you can just use it straight out of the box. And that's the mere mortals implementation, as opposed to, say, a Grasshopper script that does the equivalent thing, but it has a very fragile instantiation environment where you need the certain plugins and all sorts of stuff to be in exactly the right place for it to work.
Yeah.
We want to be a web app where you don't have to think about any of that. So that's the mere mortals test. And then the other is the easy to use test. If it's easier, people will use it. And that's it.
Mm-hmm.
If
Convenience
it's easier
wins.
for them, they'll use it. If it's not, they won't. And so
Right.
mere mortals and ease of use test, that usually leads you to the right answers from the standpoint of a software product.
It is pretty incredible that SketchUp got that so right so long ago, right?
Yeah.
Because how many icons in the UI are driving SketchUp that most people use on a day-to-day basis? It's like 5 tools. And those are the ones that are right there and easy to use, and is, of course, this is why it won so big in the industry. So it's kind of refreshing to hear that, because yeah, software is powerful, but if most people can't use it, then it's not going to get adopted. And I think this is the hurdle that we have to overcome as an industry, which is the ever increasing gap between innovation and adoption, right?
Yeah.
Adoption is so difficult. I've led digital practice at a large firm, and adoption is so hard because the deadline of the current project is the only thing that matters to most people. And so when do I have time to learn? When do I have time to try a new tool that maybe or maybe isn't going to work? So it's again, refreshing to hear this. And I want to reiterate what you just said about it being a web app. Can you just kind of go around explain why you decided to release Schema as a web app versus on a workstation based app or an installation based app? Because I don't want it to go unnoticed. The major pros, obviously there are some cons. You have to be connected, et cetera. So maybe you can talk through some of those, but the whole idea of what you said about Grasshopper and making sure the scripts are all installed on everybody's machine so that they can run the tools that they need to do the feasibility study, and like that's a nightmare for a lot of CAD and BIM and IT people to have to manage. And if they don't have to manage that stuff with a piece of software as powerful as this, I mean, that is another reason to take a serious look at it.
Yeah, we're not saying that people shouldn't do that, because they get a lot of value from making something that 10 people find useful. So, for us, Schema, we haven't implemented it yet, but it's going to be a Grasshopper host so that you can take your facade script and actually generate it in Schema just like you would in Grasshopper. But for the 80% of the stuff that everybody needs to be able to use out of the box, that'll just be native in Schema so that people don't have to understand how to instantiate it or what they need to do to get it to start. So I'm not sure if that answered your question.
Well, just the cloud-based aspect of it.
Yeah,
So
the cloud-based aspect.
why did you decide to go down that road?
Well, I think just because everything's headed there. By doing this as a web app, if my goal is to connect design to construction, it's very difficult to do that in desktop-based software, right? Because I see a future where we have an ecosystem of connected web apps that use web services to talk to each other. We've done a few of those things just in Schema already, just to show this way. as opposed to, and I'm not against platforms. Dassault is a very powerful platform. Autodesk is a very powerful platform. But the idea of a platform as the guardian of your data is one approach to putting things on the web. The other is that you've got a series of apps, kind of like a peer-to-peer, where they can talk to each other. And that's basically what we're doing. So we've, for instance, on some of the simulation, we've done an integration with Cove Tool because people are used to some of the Cove Tool daylighting UIs and some of the other things that Cove Tool does. So we just did a direct schema to Cove Tool integration. We're generating architectural BIM data, but when you move from, say, fully modular solutions like what we had done previously to things that combine engineer to order normal construction with modular pieces, you need primary frame again, right, to hold things up. So we've done some work with Thornton Tomasetti to take the block and stack cubes that generate the architectural scope in Revit to their asterisk product that generates the structural scope BIM model at high LOD, so that we can generate both and that they actually come out pre-coordinated. And then from those two models, we can generate, using other AI vendors, MEP systems that are also pre-coordinated with the architecture and structure. So I see that the ecosystem of connected web apps is going to be able to solve things that have not been solvable in the desktop environment. And that there's going to be so much value unlocked from that it'll be a massive structural advantage for those that are participating in that way. And eventually, if you really want to impact construction, you have to impact the actual construction delivery process. So starting from procurement all the way to how things get sourced and made and delivered and installed on site. So to some extent, we'll systemize the front end of that so that people can take advantage of that and systematize the back end. We might also end up systematizing some of the back end things like procurement, and possibly even doing revenue share with designers so that they get some of the benefits of having done the modeling work without having to take on the liability of the means and method risks that they can't do because of insurance. So by doing this on the web, you open up a number of interesting business opportunities and models that just are not feasible with desktop software.
And just thinking about it from a development standpoint and releasing tools and bug fixes and updates, and how great is it when it's so transparent that I don't even have to think about clicking a button that might nuke my project. I mean, you take on that liability as the company, I guess, but just that the new tools, it's always running on the most current version. This is also another nightmare for BIM managers around the world, right? Which is how long do we keep it in that version? Is everybody on that version? And just the amount of communication that has to happen around those kind of decisions is incredible and complete waste when you look at it from the big picture.
What's interesting, the other thing about this is it's interesting that this learns from your previous Revit projects, but once you have it in a schema catalog, you don't have to think about Revit versions anymore.
Interesting.
That might make life a little easier.
One of the things that you showed was and you talked about it here, is this idea of these catalog items getting plugged into the schema model.
Right.
How squishy are they? Because one of the questions I'm sure people have floating around in their mind is, different depth to width ratios, and if the schema model is one thing, but my catalog item is another, how does it adjust for that?
So when we talk about the catalog, we're talking about knowledge encapsulated in a Revit artifact from a previous project. So, if I think about CAD, like AutoCAD, that's data, lines, arcs, and circles. Then it goes data, information, knowledge, wisdom. So data is lines, arcs, and circles. Information is objects, walls, doors, windows. That's why it's building information modeling. And we're bumping it up to knowledge. So the knowledge is encapsulated with how that surgery suite was laid out, or how that exam suite is laid out. And we're pulling that into a concept catalog and schema. And then the main part of what is so big about the release that we're putting out in November is that, you lay out the circulation and the exiting, and then you can lay out things that are regular size based on what you previously did, but you will have leftover spaces that aren't the same size and shape. And what Schema understands how to do is take the logic of the layout that it has in the catalog and morph it into the target size and shape, respecting minimum, maximum distances and target areas to give you a workable layout. Now you can come back and edit it all in Revit after the fact because it's all native Revit stuff that you can edit. But the whole point about taking data which represents knowledge over decades and reusing it in a systematic fashion so that it's much faster to get to a result design is the main thing about the catalog. And so, people might ask who are, Revit users, is there a family editor for the catalog? Yeah, it's called Revit. Whatever you put in Revit, you can put into the catalog. It's just a matter of that's the way it works. So, people that have been using this on projects at some of our early firms, they realize, oh, well, if I want actually standards of quality in my architecture practice around sustainable materials in the projects, I can just do that by loading them into the catalogs that people use. And then by default, it'll be the easiest thing for them to do is just use that. And it's the opposite of the garbage in, garbage out. If I want great stuff coming out the back, I put great stuff into the catalog and then great stuff comes out the back on all the projects. So firm principles that our technology leaders are thinking about it that way is that they have the opportunity to enforce quality and sustainability through this catalog mechanism, which is a lever that they haven't had in the past. Not only that, it's a lot of some of these artifacts were done by senior designers who aren't at the firm anymore. So
it's
you can't go ask them how to lay out that
Yeah.
surgery suite, but here you have 10 of them that have been sitting on a file server somewhere for 10 years.
Right.
And now you get to leverage it and look at it in a new context of design for a new facility, and then sit down with our architect and say, is this a good layout? Is this a bad layout? How would we do this differently? And then you can go back and update it in the catalog and then use it all. It's a way of systematically improving your future projects by harvesting what you have on current and previous projects.
So is that what people shift to? There's people who are, like you said, going to be disrupted in their normal 2-hour or 2-month long CD drawing phase or end of DD, beginning of CD. So if that's gone, that amount of time is gone and the people aren't needed to do that because the tool's doing it for you, what are people shifting to? What do you think about that?
So most of that acceleration happens in the DD process. And in fact, this was recognized by some of the principals that we showed this to in these charrettes, where they said, we've done this in the past where we've done a block and stack in Grasshopper, and then we have guys go spend a couple months to model this in Revit. What we find out is that when we get to the end of the 2 months in Revit, what we have in Revit doesn't match what we had in Grasshopper, because we take those blocks and we start out with cubes in Revit and we start blocking things in, but Revit's parametric. Somebody makes a decision to move a wall over and then that propagates and something else moves over. And that's just the way Revit is, right? It propagates changes to keep things consistent so the construction drawings stay coordinated. But what it does is over 2 months, you have the net effect of all of those changes, which in this format represents variance. You have what you started off with in concept design, and now you ended up with something else in production because those people working for 2 months introduced a bunch of variance because they have an accumulated set of decisions. One of the things about Skema is that it avoids all that because it starts with these block and stack and immediately generates the same Revit data out of that. They absolutely match. All of the exiting, all of the sizes of things are the same in both. The cubes in the block and stack are the same as where the walls are in the Revit model that comes out of it. And I should say, by the way, that I'm saying Revit a lot, and we use Revit in a lot of the examples because Revit has so much market share. But for us, we're kind of BIM agnostic. Input to the catalog can come from any BIM system. It could come from anything done by Graphisoft or Nemetschek or just even Dassault Systems. And on the output side, it can go to any BIM system too. So while we're saying very Revit specific, and that's where our hearts are, obviously having built it and knowing we have a lot of tribal knowledge about Revit, which is why when we do one of these things and we do a presentation after one of these charrettes in the office with people, we get just as many questions about how the Revit data is structured as how Skema works, right? People really are, they have strong convictions about the way they should structure Revit data. And so usually we have all the right answers to those questions. So that's
who better to ask
to them.
Yeah.
But that's not to say that you can't use it with some other BIM system. I mean, it's absolutely, there's nothing prohibiting anybody from applying it with different inputs and outputs than Revit inputs or Revit outputs.
It's got to make it a great presentation and communication tool then, right? Because if you can kind of dial it back to the blocking and stacking schema, totally assured that it's going to match up with what Revit is going to show, then because a lot of clients don't speak Revit, they don't speak
Right.
plans, they don't
Yeah.
speak those kinds of things. And if you can simplify that and show them in a graphical, experiential way the kinds of things that you're trying to communicate with them, but again, be assured that it's going to work with what you've got in Revit.
Mhm.
This is a big deal.
Yeah, and I up on our blog, I have a video I did of just taking block and stack output from Schema into Veris in Revit and just doing AI generated imagery very early on the project, just to show a client, does this feel right? But having the geometry be correct about the way that, where the buildings will actually be and how big they'll actually be and that sort of stuff to guide Veris into producing the right size of image. And it's still very early days on all that AI image generation stuff. I mean, you get into, sometimes you still get into weird scale problems that, people in AEC tech circles will talk about. But I'm sure those things will get solved. But yeah, from the standpoint of just taking the conceptual data and using that on its own merits, it's absolutely valid.
Yeah, awesome. Well, what have we missed in this conversation that you want to make sure that the audience hears about? You've got a new website domain name launching. You've got this
it's
version.
live as of today, schema.ai.
Okay, and that's SKEMA.ai.
SKEMA.ai, yep.
All right, and so people can find out more information there. Where else should they be watching for all things Schema as we move forward? Anywhere else?
I would say mainly the website. I will be speaking next week. Well, this will air after that. I'll be speaking at AEC Tech in New York. And then you can come see us if you're going to be at Autodesk University. We're not exhibiting, but we will be at the show and
guerrilla marketing.
Yeah, guerrilla marketing.
Back to the early Revit days.
Exactly.
Right. Awesome. Well, Marty, thanks so much. This has been a really fun conversation. I love the history part of it, and I love where it's going. So looking forward to future updates, and I'm sure we'll have to have you back to do some catch up once you get through this launch and see where things are going.
Thanks so much. It was a lot of fun.